In the Unit 4, Section 4 lab, we're going to explore the concept of limiting reactants by creating chalk from two components, calcium chloride and sodium carbonate. We're going to mix these together into some distilled water, create our chalk, and try to predict which reactant will be limiting and which reactant will be in excess. Without further ado, let's get into it. Before we start talking about our procedure, let's take a look at our two chemicals. Our first chemical, calcium chloride, is relatively benign. It's not very harmful, but it can dry out your skin, and more importantly, it can be harmful if it gets in your eyes. Really, the only protection here where you have to really worry about is our safety goggles. If any gets on your skin, wash it off, and if any gets on your clothes, just brush it off. Our second chemical, sodium carbonate, is even less harmful. We obviously don't want to ingest it. We don't want to get it in our eyes, but as long as we're wearing our safety goggles and using it appropriately, we'll be okay. Again, wash your hands if you get it on your hands, and brush it off your clothes if it gets on your clothes. Now, the first thing we need to do in lab is to weigh our filter paper. At the very end of our lab, our product, our chalk, is going to be stuck to this filter paper. So we'll need to subtract the weight of the filter paper out after the lab is over. First things first, I'm going to write my name on this so that when my sample is complete, I'll be able to figure out which sample is mine. So now that I have my name on it, I'll put it on the scale, and this is the weight I will record. My filter paper is 0.37 grams. Make sure to record this weight exactly as it is on the scale before you do anything else. The next thing we'll need to do is weigh out our samples. I'm going to start with sodium carbonate. That's my Na2CO3. What I'll do is I'll place a clean, dry beaker on the scale, and I'll press 0. So now whatever I put in this beaker is just sodium carbonate, Na2CO3. This is arguably the more important of our two sample weights. We want to weigh as close to 1 gram as possible, so 1.00 grams. So for my Na2CO3, I'm going to weigh out as close to 1 gram as possible. And this is true for every group. Every group will weigh out as close to 1 gram as possible. Now you can see this isn't a lot of sample, but it's not a small amount either. So be careful, tap kind of your wrist or your hand as you get close to 1 gram, and we are good. Oh, I went a little bit over. That's okay. Plus or minus 0.01 or 0.02, that's okay. If possible, try to get 1.00 grams on the dot. Now we want to record this weight for our Na2CO3. For our second sample, calcium chloride, we'll do the same thing. We'll place a new beaker on the scale and press 0. And now we need to weigh our calcium chloride, our CaCl2. For this sample, you will have a certain amount for your group that you want to target, and that will be different for groups across the class. The idea is different groups will have different results, but will create a class set of data at the end. For my sample, I'm going to weigh out 0.50 grams. Your group's amount might be different. So I'll scoop some of my calcium chloride into my beaker. Calcium chloride is the sample that looks like little granules. I'll scoop it out. I'll get as close to 0.5 as possible, 0.50. If this result is a little bit off of your mark, that's okay. We want to be close, but we don't have to be quite as careful. Now, I went a little bit too far over. I'd prefer to get a little bit closer to 0.50 if that was my target, but this honestly doesn't mess up my final results. Make sure to record this amount for your CaCl2, your calcium chloride. Now for the next part of lab, we're going to be dissolving our two samples, our calcium chloride and our sodium carbonate, in distilled water. Make sure for this lab you are only using distilled water in the bottle. If you use tap water, your results will be off. So first, I'll squirt some distilled water in my calcium chloride. This should dissolve pretty easily. You probably don't need a lot of water. I might have used more than I needed to. And then simply swirl your sample until it dissolves. Should take no more than 30 seconds or so. Your sodium carbonate is a little more difficult to dissolve. You may need to use a little bit of water, but I'll squirt some in the start. And again, gently swirl this. You might notice this is not necessarily going to dissolve after 30 seconds. You may have to keep swirling. I'll also have some hot plates out. If it's really having trouble dissolving, you could put in a little more water. You don't have to put in too much. Or you might put it on the hot plate to help this dissolve. But again, swirl for 30 seconds, a minute, maybe give it some heat on a hot plate until this fully dissolves. Now, the next part of the lab is very simple. With my two samples dissolved, we're going to mix them together. I'm going to mix the calcium chloride into the sodium carbonate, but really it doesn't matter which you mix into which. I'll pour it in. And now we want to make sure we get all of the calcium chloride in this beaker. What I'll do is I'll hold this beaker over my other, and I'll squirt the sides with some fresh distilled water to rinse out any reactant that is not reacted. Now that this is rinsed and I have all the calcium chloride out, I will stir my mixture with a glass stir rod to make sure the reaction is complete. And that really is the reaction of chalk. We actually have some chalk suspended in this water. Now, let's filter it out. And now comes the part of the lab that requires a little bit of hand skills. We're going to need a few things: our vacuum flask, a Buchner funnel with a rubber stopper attached, our filter paper that we weighed at the start, and our sample. What we'll do is we'll place the Buchner funnel into our vacuum flask and just push it on gently so that it's snug in there. We'll then take our filter paper, and I recommend putting your name side down in the Buchner funnel. And what I'm going to do is I'm going to take a little bit of distilled water and wet that paper so it sticks well to the Buchner funnel. Now we have to pour our sample on the filter paper to filter out all that water to get the chalk by itself. I'll need to use this rubber tubing and attach it to the yellow vacuum line in the lab, and the other end to my vacuum flask, like so. Now what will happen is when I turn on the vacuum, you'll actually hear it start sucking air through the filter. You might be able to hear it very gently sucking air from over top through this Buchner funnel. I'm now going to pour my sample into the funnel slowly so that the chalk doesn't go past the filter. What I recommend is actually first taking my stir rod, and I'm going to wash off any chalk from my stir rod onto the filter paper. We want to make sure we get all of that chalk in as possible. I'll now slowly pour my sample into or onto the filter paper. Don't pour it all on at once, or it'll go straight through the funnel into the flask. So I'm pouring slowly. The water is being sucked out through the flask. And keep doing this until your whole sample has been poured through. Again, the name of the game is to pour very slowly. Notice that even though I poured slowly, I still have some chalk on the side of my beaker. What I'll do is I'll rinse that chalk with my distilled water to make sure it all goes in the flask, even the stuff that's still on the sides. You want to make sure you get all of your product onto the filter. That's how we're going to test our limiting reactants. This might take 2 or 3 washes to get all the chalk on the filter. And again, you want to go very slowly to make sure you get all your product, but it doesn't go down through the Buchner funnel. You want to get it caught on the filter. Let this go for a good 20 seconds to dry out, and then actually wash the filter with some distilled water. This washes any residual salt through the filter while keeping the chalk behind. So wash this maybe once, let the vacuum suck it dry, wash it twice, let the vacuum suck it dry, and maybe a third time for good luck, and let the vacuum suck it dry. Once this has been washed, maybe 2 or 3 times, and it looks dry on top, you can turn off the vacuum. Now I still hear the vacuum kind of sucking this as it's kind of coming to equilibrium. You can actually cut that vacuum by pulling up the rubber stopper. And now the last step is to take a pair of tweezers to get your sample out of the Buchner funnel. I will carefully take the filter paper out of the funnel and place it on a watch glass. Now the last step will be to put this in the oven to dry overnight. And now that I have a dry sample the next day after lab, I'm going to take my filter paper with my chalk on it. I'll zero this scale so that it reads 0, and I'll place my sample on the scale. Now remember, this weight includes the weight of the filter paper. So subtract out that 0.37 you got at the start, or whatever your filter paper weighed, to get just the weight of your chalk. And check to see, does your final weight of chalk match what your stoichiometry predicted? And make sure to consider limiting reactants when making this determination. We'll come back together, assemble all of our class data, and see if limiting reactants has an effect on the amount of product created.